Hello, good afternoon. Welcome to the computer science info session. And so today we're going to learn about the program, and we're going to also have a student to share the experience. So to start, let's first acknowledge the traditional territory upon which we gather. McMaster University is located on the traditional territories of Mississauga and Haudenosaunee nations, and within the land protected by the Dish with One Spoon, Wampum Agreement. That wampum uses the symbolism of a dish to represent the territory, and the one spoon to represent the people are to share the resources of the land and only take what they need. My name is Rong Zhen. I'm an acting chair of the Department of Computing and Software. So I'm here today to share with you some information about our curriculum, and I'll talk about the mission process. And we have our wonderful fourth-year comp sci student who just came in, Jawalet Minwale, who will also share his experience in the program later. So let's start from the basic question that might be on everybody's mind. Really, what is computer science? So oftentimes, when people talk about computer science, they tend to just equal that to coding. But computer science is actually so much more than coding. Computer science is the study of information, computation, and how to automate processes using computers. So if you think about the mission of our program is actually to train students to become computational thinkers, not just coders. To be a computational thinker, you should have the ability to break down messy, big, real-world problems into smaller, manageable parts that are called decomposition. As a computational thinker, you should be able to distill through the noises, eliminate the irrelevant information, so you can get down to what really matters for the problem at hand. A computational thinker should be able to identify patterns that are in common across potentially a variety of tasks, and design step-by-step solutions to those problems. So to make things a little bit more concrete, so I know this sounds like a bunch of terminologies I'm throwing at you, but let's take a real-world example, or an example that may happen in the near future. How are you going to teach a robot who has never had experience to make a peanut butter jelly sandwich? So can I have some suggestions how you go about and solve this problem? How you teach, or maybe your younger ones, or your little sisters and brothers, how to make peanut butter jelly sandwich? Any idea? Go ahead.
Tell them what peanut butter and what jelly and what means, like define the variables, I guess.
Okay, first define what those ingredients are,
Yeah.
And
then I would put in the smaller steps. So first, lay out the bread, and then
okay,
I'd say put peanut butter and then put jelly, and
okay.
then put the bread together.
Okay, so you break it down into steps. So you're gonna put the bread on a table or a plate, and then you spread the peanut butter and jelly, and then you put them together, and you're done, right? That's your answer. Anyone want to add to that? Yes?
Create a planning of how to supply these ingredients, what you want, and tell them what is the mix they have to do, what is the steps to do. But critical is more than
Okay.
algorithm or computing them, feeding all the input material.
Okay.
That's the most critical one to make the robot or any automation way to create.
Okay.
But
So you mean that how do you streamline the process? That's the most challenging part, or
how do we supply the ingredients to the
supply the ingredients? Okay.
in a more efficient,
Uh-huh.
measurable, quantitative way.
Okay. I think you are one step ahead of me. You're thinking of making peanut butter maybe on an assembly line to make, thousands of them, maybe for the 4.0. But I'm talking about one peanut butter.
At home, without the ingredients, so we cannot make it. So making those ingredients of the supply chain,
Yeah.
I'm not talking about the factory.
Okay.
Even at home, like you need a small quantities in an accessible way to take a.
Yeah. Okay, I think that's very important. You need to source the ingredient first. Maybe you need to go to the grocery store to get the necessary ingredient in order to make the sandwich. Anyone else? Or maybe go ahead.
You need to be extremely specific with the steps when telling the robot what to do.
Okay, can you give an example? You said you need to be very specific. Like, can you give an example, like how specific you need to get?
When you tell the robot to take peanut butter out of the jar, you need to specify that you have to open it first. And then you have to do the top.
All right.
So maybe even specify the method of opening it.
Okay. So, sorry, what's your name? Jay mentioned you have to be very specific in telling robot what to do in every single step. Like, for instance, you have to explicitly say you need to open the jar, right? So that's an absolutely excellent point. So you can see just through the discussion we just had, like, despite this seems to be a super simple task, but it's actually quite a bit of complexity to it. If you do not give the sufficient detailed and specific instruction, then you may have all kind of chaos in your kitchen. You may have, as Jake mentioned, that if you didn't tell the robot or your smart kid, like not open the lid first, then you may have the robot just cut the knife through the lid to get the peanut butter. You may have situations that if you do not specify, okay, just spread enough on the bread to cover it, you may have a situation that you just have way too much peanut butter. And last but not least, when you say you want to put those two slices together, it can go all ways, right? In fact, as you probably can tell, those pictures are generated by ChatGPT. When I try to create the last image, I try very hard. I want to show peanut butter and jelly are both on the outside of the sandwich, but I tried 10 minutes. This is the best thing I got in the end. But I hope that shows the kind of at least make the point that you have to be specific. Like when you put those slices together, make sure the ingredients are on the inside, not the outside. But it also, this little experience that I had also showed that AI are actually not as powerful as we think they are. So from this example, I hope you kind of get a sense, like, for a seemingly simple problem, like making peanut butter sandwich, there actually requires some serious computational thinking. In particular, in order to teach robot to do so, we first need to break down this complex task, like starting from sourcing the ingredient, like the gentleman just suggested, and the task of spread the peanut butter and jelly on the sandwich, and then the task of putting the slice together and then clean up. And then within each of the subtasks, then we need to specify a procedure. Like that's correspond to essentially the algorithmic design. Like how do you spread peanut butter jelly? So you have to open the jar. First step is open the jar. Second step, pick up the knife. So this becomes something that the robot can execute. Abstraction is also in this problem. So you may have multiple jars of different brand of peanut butter in your refrigerator, but as far as this task goes, it doesn't matter. So we all abstracted out as peanut butter. Or maybe you have a creamy or crunchy peanut butter, doesn't matter. So it's exactly the same step the robot has to go through. And finally, if you spend so much time teach the robot or your little kid to prepare a peanut butter jelly sandwich, what if next day you need to prepare a different kind of sandwich? Some of those modular skills are actually transferable. They are actually shared across different tasks. That is pattern recognition, for instance. Open the jar requires 20 twisting the lid that is applicable to many everyday tasks, and using the knife to spread the jelly or peanut butter, again, can be relevant to many daily tasks. So those are just some examples. If you think about this process, there are actually quite a bit of computational thinking behind them. So I know that many of you, kind of have some kind of anxiety about the job prospect of computer science graduate with this boom of AI. Like everybody's kind of asking, like, are our job going to be automated away? So to be frank, yes, it is true that to some extent routine tasks will be increasingly automated, like routine tasks such as kind of repetitive programming or coding, basics testing or documentation. Those type of job descriptions will be less and less, and they tend to be replaced by AI. However, computer science trains students with computational thinking, and in this age of AI, I would argue that those skill sets of computational thinking will become even more valuable, in particular to define, based on user requirement, like peanut butter, whether you want to leave the crust on or not, that, people have different preference. You need to extract that from user in terms of defining what to build and how to get it work. And not only just get it work functionally, but also you want to make sure your product is safe for the environment, for other people. So those kind of skill sets will remain relevant or become even more valuable. Additionally, think about the AI boom. There are also new job opportunities that can be created, such as AI engineer, data scientists, human-AI interaction designers, domain-aware AI specialists in different industries such as health, finance, climate, mobility. There's also a huge demand in system engineer who are able to, deploy AI models on the edge on your mobile devices that can operate even without network connectivity, or people who can improve the efficiency of running large models in cloud data center without consuming so much electric power. So therefore, I would argue in the age of AI, the most resilient graduate should be able to combine computer science fundamental with AI literacy and domain insight. So why study computer science in my master engineering? So computer science is part of Faculty of Engineering. As a result, it also involves a lot of hands-on experience and teamwork, and the program also offers a lot of flexibility. But unlike the other engineering program, so this is a direct entry program, so it actually confers a Bachelor of Applied Science degree. And compared to other engineering programs, it's also very flexible. It has in total 10 open electives and 6 technical electives. So that allows the ability for students, if they want to pursue a minor on the side, they can use those electives to do so. And I will later talk about, we have computer science students also have the option to have pursue co-op, and my master offer very flexible co-op program. So in the past decade, the department itself has grown quite a lot. So we almost doubled the number of faculty members, and our professors are actually working on cutting-edge research in a variety of domains. You have people in the department working on magnetic actuated soft robot for surgical applications. We have professors working on medical imaging diagnosis for cancer treatment. We have people working on computer animation to animate character based on musical inputs or text inputs. We have people working on remote sensing for vital sign in health monitoring scenarios. So basically, if anything can think about from teaching robots to make PPG sandwiches to planetary AI, it is actually something that computer science can offer. So I'm going to talk a little about your experience here. in the first year, so you will take a number of courses, like I said, because it's a direct entry program, so you have those courses that are relevant to computer science immediately in the first year. Courses, foundational courses such as Introduction to Computational Thinking, Introduction to Programming, but of course also math courses, and some experiential learning course in software development and software design. And in addition, even for the first year, we'll have 2 electives that students can take. So if you never had any experience in programming, that is okay, because that's what the first year program is for. We'll be able to mitigate any kind of knowledge gap and provide you the foundational knowledge that's needed for you to advance in the program. In the last year, students have the opportunity to participate in, actually it's part of the requirement, to take a 1-year-long course group project as to complete the degree program requirements. So typically those projects would involve working in teams and develop computational solutions that to address some relevant real-world problems. So a variety of capstone projects students have worked on, go all the way from AI games to some kind of open source product for social goods. And students will have the opportunity to present and showcase their work through this engineering expo towards the end of the, typically the winter term. So we have people from different engineering programs, students from different engineering programs to present the project. We also have visitors from like alumni, industrial partners, community partners to get to see the great work that our students have done. So this 1-year capstone project is really the opportunity to bring together everything you learned so far in the program into something that hopefully can solve a real-world problem. So the co-op program in my master is very flexible. Student has, if at admission you have the opportunity to choose apply to CS and co-op, or if you decided to defer your decision, you can always, even if you just apply and admitted in CS, and you have the option to later participate in the co-op program. So as long as you meet the minimum requirement of 12 months of co-op experience, then you will have that designation in your degree. And you can divide the 12 months requirement in many different ways. For instance, you can do 4 3 summer months, 4 summer months each year, or you could have like an 8-month co-op plus a 1 summer month. And you could even have longer co-op experience, such as you can do like 6 months or up to like 28 months of work experience. Of course, depending on how when you do that, so it may imply the total duration of the program will go beyond 4 years. So many companies hire and value our graduates. In addition to those, high-profile IT companies, our graduates also get to work in manufacturing, in finance, in many other small business successfully. So as I already mentioned earlier about the research our faculty members doing, my master engineering also provide opportunities for undergrad students to participate in research. Like every summer, over 500 students will get the opportunity to take on undergrad research position. Oftentimes they work very closely with some professors on a research project. And some of them are actually supported by the entrance scholarship provided by engineering to work on those projects. So by comparison, my master actually offered the largest undergrad engineering research experience program in Canada. So on your way from JHE over here, you probably already check out some of the fun activity offered by the club. So there are many clubs in faculty engineering. And those clubs actually have offer a variety of experiences from programming to design of Mars rovers to putting together a music show. So there are really a lot of interesting activity to get involved that can enrich your experience here. For student support, there are many resources available on campus, both in the department, at the faculty level, or in the university, can offer academic advising. There's a Center for Career Growth and Experience that supports students become career ready. And in engineering, there's a top spot program that is dedicated for mental health service that offer a same-day counseling to students, and there are also additional student university services for student accessibility needs and the BIPOC student support. So now I'd like to turn to Javalet to share his experience in our program.
Thank you so much. So I'll start off with just sharing a bit of my experience with McMaster over the past 4 years that I've been here. So as you saw on the slides, that in your first year, you typically have 5 computer science courses along with 3 math courses and 2 electives option. So using those electives at McMaster, I have completed my minor in business as well, alongside major with computer science. And during the 4 years of computer science, I've been able to take part in so many different courses which has projects and which have some different kind of learnings. Like I've learned about a lot of UI, UX plus security and lot of about the data structures and algorithms as well. Now the reason why I chose computer science at McMaster was mainly because of my passion towards software and coding aspect. And another aspect was that McMaster offers a direct entry into computer science, unlike the engineering stream, which has first year common. So that was one of the main key reasons for me to choose computer science and actually practically implement all my coding into real problems. Now, over the past 4 years, I've had different internships, research opportunities, but one of the notable co-op experiences during this period was my 12 months of co-op experience as a cybersecurity analyst at Purolator, which was last fall till this summer. And during that, it was a great experience for me to actually take all my theoretical and understanding from university and implement it into a real life experience at an organization, where I was able to learn a lot, plus also give a lot to that organization with within the spectrums of penetration testing, risk management, identity and access management, and a lot of other operational things. One of the reasons why this co-op was very notable for me was because of the amount of practical exposure I had at this organization, because there are some fields which you might not be able to actually practice at a day-to-day level, but when you go into an organization, you actually see how they work, how tools works, how you can actually implement those things. And yeah, the guidance and the mentorship over there that I got was also insane, and due to which co-op is one of the places I feel you can try and test it out, how you want to grow yourself in the future, right? As you saw the slides earlier about how you can break your co-ops in the 4 years, I feel you can try and test out different roles, because in computer science as Prof mentioned, it's not just about coding, right? So it's not just about software development. There are so many sub-fields under it which you can always be part of, right? So using your co-op, you can maybe try, 4 months of software developer role, then 4 months you can be a web developer, another 4 months you can probably go into data analyst and AI, and you can, divide yourself up and see what fits right for you and what you want to do as a full-time employee, right? So that was one of the great experiences for me at Purolator. Now coming to some of my club and teams experiences, as you saw, there are more than 70 plus technical clubs, which means that you actually are doing something related to your field. We have clubs like Mac AI Society, the Cybersecurity Club, the Google Developers Club, where you actually implement and test things out, do at a larger scale, which enhances your growth in terms of the things that you learn in university, right? So along with what you're learning, you can actually implement and see how things are around that. So some of the clubs that I've been part of is more of non-technical to improve my soft skills and just grow out my communication skills and other time management skills. So I've been part with the recruitment team for the past 4 years as a student ambassador, and this year I've been working with the CAS team as a student ambassador to help them with promoting computing and software department. And just to end the note here, I would say the reason why I love McMaster is because of the community that it provides here. So you have so many different professors, TAs, the recruitment team, you have the health team as well. If you have any concerns, you always can go up to those people, reach out to them, you can talk to them, and they're always ready to help you. And along with that, you have your friends in your program or apart from your program as well. You might have friends who you can reach out, and it's a very close environment where everyone's ready to help you and grow out in your future, right? So that's one of the main reasons why I love the MacEng program and the university. So if you guys have any other questions after this, feel free to reach out to me. Thank you.
Okay, thank you. We're not quite done yet. So I'll briefly talk about admission. So in order to be considered for the ComSci program, you would need at least 90%. The program is quite competitive. As such, the admission is by selection. So the target number of enrollment for 2026 is 200. So the GPA is calculated based on total of 6 4UM courses that include English, calculus, and vectors, and 2 out of that list and 2 other courses at the grade 12 level. The important deadlines are shown on the right side of the slide. Supplemental application is required for engineering programs, so computer science is no exception. So it gives you the opportunity to actually tell us more about yourself beyond the grades. You can showcase your communication skill, your critical thinking, and problem solving skill. But you only need to submit one supplementary application for all the program you applied in McMaster. The application is relatively simple to complete, only take roughly 20 minutes to complete, and it needs to include the written and the video responses. McMaster Engineering offer over $2.5 million of worth of scholarship and research award every year. So in order to apply, after you complete your application, you need to log into AwardSpring, and you provide information about any past award you have received, any extra curriculum activity and accomplishment. You need to answer 3 short answer questions and upload 1 required letter of reference. So there has to be a little change. So you could optionally upload 2, but only 1 is required. It's generally advised that you should have the required letter should come from your teacher in the school. But if you plan to submit additional requirement, may come from someone outside, like from the community. Again, 1 application is required for the entrance scholarship, for all entrance scholarships. So that's all the information I have for you today. Both Jawalit and myself will be around after the session if you have any questions, and I really look forward to hopefully meet many of you next year. Thank you.